Hello everyone, as I introduced in the previous video, I have continued to work on reactors, generators, and a plugin to support them, and I think I have some good results. First of all, we have this Brayton generator here, which is connected to the reactor that I had introduced previously. Well, at least the part had been introduced previously, but there are certain changes. First of all, you might note that there's this ish thing here, and we've got an ish reactor and ish generator. That ish is interstellar system heat because I couldn't come up with a better name. So in the previous video, I had introduced the idea of somehow combining the ideas of KSP Interstellar with the ideas of system heat. And the thing about system heat is it has this nice dialogue which shows the heat management situation, and it's much more realistic about the whole thing. It's got these heat loops and everything. But then KSP Interstellar was more realistic in having a separate reactor and generator. In the normal system heat model, these are combined into a single part, which could be nice, but doesn't offer as much flexibility. So I have this new thing, and also I'm hoping that the plugin that I made to support this, or with the help of Claude, so AI has been involved, okay? But it did a good job this time. The first try really only had 2 minor errors, and the plugin I'm using right now is the second try. So pretty good work there. But the goal here is not just to have this work like it is, but also to support radiation from the reactor. And we'll see where we go with that. I don't know if it'll be a Kerbalism kind of radiation or what. How we're going to have the radiation and shielding is something I have to think about. But for now, this part works. And let me show you that it works. So we have here a reactor that, it says 2 megawatts, but it's rounding. It really is 1.5 megawatts. And you can see the system flux is 900 kilowatts because this generator takes 600 kilowatts. So 1.5 megawatts minus 600 kilowatts is 900 kilowatts, which is what we have as waste heat here. And so heat management is reading that. I've checked the radiators. They are going to do it right. And we have here a 800 kilowatt Vastomer unit, so that it shouldn't be able to power the 800 kilowatt Vastomer unit. It should only be able to go up to 2/3 power. So we're going to take it outside and make sure it can only get to 2/3 power, but after that it starts sucking up our electric charge. Oh, did I miss the... Oops, I missed the hydrogen tank. That's important. We do need hydrogen still. Okay, there we go. And full power. We see that we are draining about 200 kilowatts as expected because this is an 800 kilowatt unit. And we are producing only 600 kilowatts. And that is increasing as expected. That's the loop temperature, but it should stabilize at 900 because we have enough radiator capacity. Also importantly, if we turn on SAS and take a look at our apoapsis and periapsis, we should see that it continues to work with warp thrust. That's no problem. Though it suddenly went off for some reason. Oh, because we lost electric charge, that's why. So we'll have to restart that. But if we throttle down, it will be stable. Here we've got the electric charge stable at about 2/3 as expected. Let's actually get to 2/3. And then during time warp, it's replenishing and it can continue. So that's all good. But there are curious situations. Let's go back to the spaceplane hangar. So the generator has to be directly attached to the reactor. That's the same as KSP Interstellar. So if we type in ish here, if I put it here, there's a reactor here, but it only sees one attached reactor. Okay, and even if it did read the reactor, well, in this case it should be fine. it should produce extra power. Activate reactor. Now it's producing 1.2 megawatts, really. It's not reading 1.2. But now our system heat is double because we've got this extra reactor also doing 900 kilowatts, so we've got a total of 1.8 kilowatts. But this generator, I haven't written in a power output limit yet, but there is a field for that. So there would be a power output limit for it. It's just that it's not active right now. It can effectively take as many reactors as we want to attach to it. And so if we, instead of doing this way, sneakily, oh, that's the root part. Let's reroute. Let's have, oh, I don't know, 4. Whatever. Just demonstrating after all. This is a horrible way to put things, but 4 attached reactors, 2 megawatts. So it should probably be 2.4. I don't know if I can convince it to give me an extra decimal place there. We'll see. Anyway, so it can do that. But then you might be wondering, okay, but what happens when you have 2 generators? Well, this reactor only produces a certain amount, right? 1.5 megawatt. So if it's got 2 generators attached to it, then there's a potential problem where A, they'll be trying to draw more than 1.5 megawatt, or B, they'll draw just enough so that this doesn't produce any heat, any waste heat. It should always produce waste heat, right? Well, don't worry, we've solved that problem. So we've attached it here. You'll note that the power output's now only 300 kilowatts. This one is also now only doing 300 kilowatts. And that's because these have a factor written into them to how much they actually are able to suck out of the reactor. That's effectively the Brayton converter efficiency. And if the reactor detects that there's more than one generator attached to it, it divides the requested amount by how many generators there are. So it won't output more than its capability or diminish the amount of waste heat that it's going to produce. If one of the generators was more efficient, then that would be able to do a little bit more. It might not do 300, it'd be doing 350. And instead of having 2 generators, it'd be much better to just have the one efficient generator instead of one bad one and one good one. So that's how it'd be. If you have a better generator, then you're going to end up having less waste heat. This will all be released, by the way, as part of my future tech pack the next time I update it. I'm just going to get comments on this setup to see if you guys approve or whether I should make any changes before the first release. So this is the module. This is the Interstellar System Heat Reactor module. Thermal power max, nominal temperature, and then throttle ramp rate. That's just how quickly the reactor spools up. And then this is how much the reactor is willing to give the generators. So it'll never have less waste heat than 35%. It'll be willing to give 65% of its thermal power to the generators. So it'll always have at least 35% waste heat, is what that's saying. And so you can increase that to 1, that's fine. If you increase that to 1, that the amount that's taken by the generators is still going to be limited by their claim fraction. So what this is saying is that the Brayton converter has an efficiency of 40%. So it's able to take, because we have to negotiate how system heat is eventually going to calculate this, the way it's being done is by the converters / generator claiming a certain amount of thermal energy from the reactor and letting the reactor emit the rest as waste heat. Okay, so the amount it's claiming is 40%, which represents its efficiency. So this efficiency up here is not that efficiency really. Well, it's the efficiency of how much it's going to take from the reactor, but then you could diminish this to indicate how much it fails to generate in electricity, but that'd be complicated anyway. If I wanted to limit how much this size reactor can take from, this size generator can take from the reactors, if it has like 2 or 4 reactors attached to it, we can set that here. So if I'm saying that this thing can only take 1.2 megawatts total, so therefore it would only be able to deal with 2 of those reactors, then we set it like that, 1,200. And maybe I'll just save it like that. So that is the idea, and that's how these 2 modules work together with system heat to do their job. There is a little radiation rate max associated with the reactor, and so there is a field there that I haven't used. I haven't figured out exactly how I want to do the radiation, because I want to make shields, the shadow shields, actually effective. But if we do that, how do we do that? Because it's very dependent on the shape of the ship and geometry. It somehow has to establish an angle from the shadow shield to cover the ship. And that is a whole lot of complicated math. I have a calculator for that business, but that doesn't mean it's going to be easy to implement in Kerbal. So anyway, that's the idea. That's how these work. And they seem to be working with system heat just fine. But they're a custom little module that I'll get to manipulate in different ways. So that's how the reactor and generator... And of course I am looking into how to do a thermal nozzle as well. So it would be possible for you to have this reactor, the generator taking some of the thermal output, and then the rest of the thermal output being sent into the thermal nozzle. And that's also where this reactor's limit, that 65% that's willing to give up, and it will definitely make the rest waste heat, is important. Because there's always a certain amount of waste heat, even with thermal nozzle. And so in this case, this will be taking 40%, the thermal nozzle will be getting some other percent, and then another percent will be emitted as waste heat. That's the idea. So you could have a bimodal system like that. So that's that's what I'm going for. And then we'll have different kinds of reactors, not just this little 1.5 megawatt thermal one. And it'll all work out somehow. All right. So that's the explanation of interstellar system heat. Not the best name. I mean, we've got KSP Interstellar, we've got system heat. I'm putting it together, and at least it has the interesting acronym-ish. With that, thank you for watching. I hope you enjoyed this video. If you did, please do press like. If you have any comments or suggestions, please leave them in the comment section below, and I'll see you next time.